We start with a demonstration of Trivim. Trivim is a free and open source software for 3D visualization of street view model from sequence of overlapping 2D images captured from various handheld cameras. This application can be downloaded from the official website of Indian Institute of Remote Sensing. The application is started by double-clicking the exe available in the Trivim folder. Opening window comprises of the complete workflow of the software, which includes camera calibration, field planning, that is an optional step, point cloud generation, image segmentation, height extraction, 3D model generation, and database query. There are two options given in starting, that is either to start by creating a new project and the other to load the already existing project by the user, that is load project. We start with creating a new project with the design name. Create new folder. And choose that folder. That gives you the database attributes entry prompt, where you can enter the variable name, for example area, and its type, that is real, and add variable, and click on OK. The first and most important step in 3D modeling is camera calibration, that is carried out for accurately determining the principal distance, principal point coordinates, focal length, format size, etc. This can be done by clicking the camera calibration button. Here you can select the particular camera name that is used. Here I am using Nikon D60. Then we need to browse for the chessboard images available in the sample data. As an example, here the gray named folder is selected. After that, we need to click on calculate parameters button. And wait till the processing of the step is complete, as seen in the command prompt window. If you are having an already created camera parameters file for the particular camera, that can be loaded by load camera parameters button, and the generated new camera parameters for Nikon D60 can be saved at a particular location on your system by save camera parameters button. After the completion of the step, click on OK. Next step is field planning. After the successful calibration of camera, field planning is carried out. We approximate the values of length of path, distance from buildings, percentage of overlap, and the time required for one photo in order to seek the number of photos and approximate time required in doing so. So, here we enter some values. Let it be the percentage overlap of photos, say for example 80%, and the time required to capture each photo is 3 seconds, and click on calculate. This gives you the number of photos required and the approximate time required. After the completion of the step, click OK. Then overlapping images are imported in Trivim software for generating 3D point cloud data. A point cloud is a set of data points in some coordinate system. In a three-dimensional coordinate system, these points are usually defined by x, y, z coordinates and often are intended to represent the external surface of an object. The point cloud generation creates 3D point cloud from a set of overlapping 2D images. This is done as clicking on the point cloud generation button. Browse for the image directory, the folder with your images. The photos, for example, are present in the sample data folder. Click on choose. Then click on the generate point cloud button, and the processing is visible in the command prompt window. Wait for the step to end and georeference button to highlight. As the processing goes on, we can look at the structure of the test project folder that the user created. When the project is created, there is an empty input and empty output folder with some text files and database files. Then on creation of a point cloud folder is generated. After the generate point cloud process stops, click on the georeference button. Georeferencing step is the one where the point cloud data generated is matched to the real world coordinates. Here you have to choose the coordinate file present in the sample data. And open. See the command prompt window. After the process ends, click on OK. Check in your test project folder, point cloud, a georef file is created. After the step comes the image segmentation. Click on image segmentation. It is used to capture the textures of the various buildings. Select the particular image. Click on show image. Then image segmentation. This gives us the dialog with the selected image. Now we need to crop the buildings, each floor. Click on one end of a particular building's floor and drag to the other end. Pressing the mouse button, a green outline appears. Click on crop button. A prompt for entering the details appears. Enter the name of the floor as build1_1 for the first building and enter some area value and click on submit. This shows a message as value saved successfully. Then click on OK. Repeat the same for each floors of all the buildings. Click on crop, enter values, and submit. Repeat the same steps for the building number 2. And finally click on OK button. You can choose the images according to you from the list as per the building requirements, and finally click on OK. The next step is the height extraction. The height extraction feature is then second hand to evaluate the real world height of all building segment created. These building segment heights are used for the 3D model generation. Click on height extraction button. Browse for the point cloud file present in your project folder named as juref.txt. Click open and then open point cloud. Click open the cloud compare application. Click OK and yes to all buttons. This gives us the point cloud. You can adjust the window according to you. Here we need to select points for each of the floors. Each floor comprises of 2 points for the extraction of the height. Select the particular cloud. Go on point list picking button and pick the required points. And save as XYZ in your project folder, heights folder. A new folder for heights is created. And save the points as 1.txt. 1 refers you to your building number 1 and save. Yes. Repeat for the second building, the third building as per your requirement, and then cross your cloud compare window. After the step, click on the extract height button. Select the heights folder of your current project. The completion of the process is showed in command prompt window, and finally click OK. The next step is 3D model generation. It compiles the planimetry, elevation and attributes information related to the building segments and reconstructs 3D models for building with fine textures that was visualized on a web portal such as Google Earth. Click on the 3D model generation button. Here first we need to load the particular areas on the particular building's KML file that is created beforehand on Google Earth. Load the footprint of building 1. We have it in sample data as build1.kml. Load the footprint for build 2, build2.kml, and click OK. Then click the construct buildings button. After that, click on the 3D visualization button, which shows us the buildings on Google Earth in this form. Close the Google Earth tab. Final step is the database query. Click on the database query button. Enter. Click on database query button. Load the attributes. This gives us the name and area attribute that we entered. Now for asking a query, write the name of the building as 1_1 and submit query. This gives us the result, and then you can save the query wherever you want in the project folder. Click save and OK. Here is the about button about the Trivim software. And the help for the user manual. This is all.